Hello and welcome back. We'll now take a closer look at the introduction to statistics. We look at descriptive statistics that allow us to characterize statistical samples, and we also look at how to avoid some common pitfalls. First, we start with a range of data points, and we look at quantities like mean or median of the sample, the variance, and others to characterize them. We use a famous example described by Anscombe in Graphs of Statistical Analysis. It's quite old, but it illustrates quite well what we want to show. So here we copy over the data points. So we have the x values here and then 4 different ranges of y values, and they are defined as a Python list. So we name them as a data set. This is a dictionary, and we use the string here indicating the Roman numbers and give it a tuple x and y. And now for each of those, we print the mean and the standard deviation. We use the NumPy package for it that conveniently provides these functions for us. Before we do this, we look at all these numbers again, and we notice that they are quite different from one another. Now, let's look at the mean and the standard deviation. And we see they're all the same. So that means that the descriptive statistics that is so often employed to characterize a data set doesn't give us the full picture. We have 4 rather different data sets. Here you see the number and the mean, the standard deviation. But the descriptive summary statistics, mean and standard deviation, is exactly the same for each of them. So this is why it's important to not just rely on numbers like mean and standard deviation or variance alone to characterize the data set. Let's plot these so we can see what we're looking at. As you can see, they are vastly different. The first one here is probably what you would expect for a linear regression type of thing. So you can imagine that the line goes through here and then the points are scattered around. But here is an extreme example. It's a different line, but this point is chosen just so that the mean and standard deviation are the same. This one is more akin to a parabola and looks quite different from all the others. And this one in particular is this line plus an extra data point. But as you can see, all the mean and variances are the same. We can take this a step further, and this is what researchers at Autodesk have done. These researchers have created a dataset they call the Datasaurus dozen. It's called like this because there are a dozen different ways of arranging data points so that they always have the same mean, standard deviation, variance, etc. And it's called the Datasaurus because they start with a fun image, the image of a dinosaur. Let's look at these. I've downloaded the data from here. You can follow the link and get the data yourself. And there's the dinosaur in it, and you can see that here is the first few data points, and we print the mean and standard deviation. And then if you do a scatter plot, you can see what they mean by a dinosaur, and this is like a little T-Rex. And now we plot all the other ones. So we have a star, or lines, or a cross, or a circle, bullseye, right, slanted and wide lines. And if you look at all of these means in x and y direction and variance in x and y directions, all these numbers are the same. Although clearly, as you can see, from the dinosaur to all the others, these data sets are vastly different. And this is what makes it so important to not just rely on descriptive statistics alone, but also to look at the distribution themselves.